Hi, everyone. I want to just share a couple of thoughts about Module 9. Module 9 was all about big ideas in math. And I think that Module 9 seems to have stretched everybody's thinking a little bit, which is great. I appreciated all of your comments. Great discussions again. I just wanted to share a couple of things that I think. So first, Daniel's question of are the big ideas set or are they subjective, or is there only one way to think about big ideas? Which way should we follow? Things like that. Um, so the biggest work in using big ideas is coming up with the big ideas. So sure, we can agree as a department to use somebody's big ideas, Marianne Smalls or Fosno's or whoever. Um, But the best thing that comes out of big ideas is when we all agree to sit down as a team and to decide what the big ideas are going to be as we as a team teach math to our students. I'll give you an example of what I mean just in a little bit. I just want to talk about a couple of other things. Um, and to add to that, there's a lot of big ideas out there. Some are better than others, depending on what you value about math education. I'll get back to that comment in a second. Jamie and Shu both asked if you share the big ideas with students or if you keep them to yourself. And again, the best work is in developing the big ideas. So the best way to do this is to have students decide what they think the big ideas were in the last unit of study. So you can kind of give them a period to decide what do you think the big takeaways are from the last month or from the last 3 weeks, and you've got your word walls up and you have your the work that they've done on chart paper that is all over the place, so they can kind of look and decide, oh, these are the big takeaways, the big underpinnings of the education. So that's what I would do with students in terms of big ideas. Am I going to map out the whole course for them in big ideas? I think that might be overwhelming, but I would definitely want them to think about what are the key learnings and the big ideas that we've come across. Um, Laura's question was great about spanning strands. So there, you saw as you were looking, some people, um, like the NCTM's definition is very, it's not strand specific, it's all of math, while Marion Smalls is strand specific. So um, they can span strands, and some people take it even further, and some people use the definition of big idea that comes from overarching learning goals that says that really we should be spanning curricula. So, for example, science and math might have similar overarching learning goals. Um, or the idea that you should be spanning grades, which is what we adopted in our department. Um, Charlene pointed out that to improve as educators, we have to continue to reevaluate our understanding of the curriculum. And that's what big ideas do. Every once in a while, we should be getting together as a department and talking about what do we think the enduring understanding is and the big learning that we want students to get out of this course, because every few years that will probably change with our experiences. As we see new students come through, they'll teach us more about what works in the course and what doesn't work in the course. I want to give you a concrete example of a big idea that we developed in my department that served us well. And our idea was that we wanted 4 to 6 big ideas that are going to span grade 9 to 12 math. One of them that I think has worked the best was mathematical models can be expressed in a variety of ways: graphs, tables, words, equations, and pictures. And each of these expressions has to agree with each other. So I'm going to show you an example of what I mean by that. So let's say that we're given this equation here, and we are asked to find the x-intercepts. Okay, so we're asked to find the x-intercepts. And in terms of equations, a student might do this. So we know that to find an x-intercept, y has to be 0 because it's on the x-axis, and anything on the x-axis has a y value of 0. So they'll start working with the equation, they'll start solving, and they'll come to a problem where they're now trying to take a square root of a negative number. So they stop and they can't answer it. So that's what the equation says about this problem. So we tried to find x-intercepts and we came across a problem. In terms of graphing it, if a student tries to graph this, it'll look like that. And again, we tried to find x-intercepts by graphing, and we seem to have come across a problem. If a student were to make a table of values and they never got a y value of 0 in their table of values, that would also share the same story. So for us, that was a very important big idea. And it ties together grade 9, ties together the fact that we can describe relationships in words. So we can say that there's positive correlation, negative correlation, linear, nonlinear. We can talk about it in terms of equations. We can talk about it in terms of tables, and everything's linear relationships. Then in grade 10, we do the same thing, but we're talking about quadratic relationships. In grade 11, we do the same thing, but we're talking about sinusoidal and exponential and all that. And then in grade 12, we do the same thing again, and now we introduce rational or radical, and we introduce radian measure and all these things. But the big idea is still the same. There are many ways to represent mathematical expressions, and all of those expressions, or there are many ways to express mathematical models, and all of those expressions have to tell us the same story. Okay, so I hope that that clarifies things a bit in terms of big ideas. If you want to continue dialogue, then please continue posting under this video because I do think that this is a worthwhile thing to consider, and it seems to have stretched everybody's thinking. So I'm happy to discuss it further. Okay, thanks.